Dot. That's on the bottom.
Mine's at the top. All right. No, that's view. I don't have a dot in the bottom.
Do you have a hang up and a...
I have a hang up and a plus and a mute and a camera. All right, so then under plus it says send files, send contacts. Oh my gosh, it was right in front of me. Share screens. I'm so sorry. It's been a long week, man.
Well, Mr. Puckett, we meet again.
Yes, we do. Something tells me we're about to have a cloud simplified conversation.
I think that's what's going to happen. So
all right, look forward to it.
Yeah. So today I know we had Laura on previously. Welcome, Laura.
Hi.
Welcome back.
Thank you.
Good to see you.
She is
good
back
to see
again.
you guys too.
Yeah. So she simplified a lot of what happens under the covers with this artificial intelligence stuff that is sometimes scary, but she made it seem not so scary and outlined some of the math and statistics that kind of work behind that to be able to make some of those features work. Today, she's going to be showing us how you can actually apply some of that to be able to solve some real world problems. So really excited to see what she's got.
Yep.
So I'm going to say this ahead of time because I'm showing you actually demonstrations of real deep learning today and neural networks, that some of this might not be as fun as the last time, but I'll try to spice it up a bit as we go through.
It's spicy enough knowing that you actually use this to beat your husband in his fantasy football. So
yes, yeah, he's banned it in his house, I hear. Is that what
it's so true. It's so true. And it's funny because like this year, this is the first time I cracked it out this year to update it. And there's so many new players and there's so many players doing bad things on their social media that it's just taken forever to retrain. I was like, it's literally been running for like 7 hours. And I was like, wow. Now, as you get more involved in machine learning, I'm sure you've heard deep learning and AI. This is this other area that a lot of people get very confused by. I'm sure you do too. So essentially what I'm going to show you today in my fantasy football model is very much in line with this deep learning method, which is taking, what you see here, and this is a very straightforward linear model on the right, where you're just trying to predict out the price of a house based on things like how many bedrooms, the square footage, the neighborhood it's in, and applying weights to how important you think those are. For me, I think it's very important to live in a neighborhood that's safe, and I actually would have wanted bedrooms to be higher, but square footage as well. So I can apply the weights that I want to it, and boom, I can then have a price estimate. But that's not the real world. That's a very simplistic model. Most situations in the real world involve a much more complex method of slicing it. There's just a ton of different avenues that you could take. And so you can't just have a simple estimation. You need to go a lot further. And that's really what I did with my model, which is super exciting because it's won year over year since I started, except for the first year, because it had to train. But since then, it's crushed it. Every season, PPR. Yes. Anyways, we'll get there. All right. So what a neural network does is it takes that first example, that very straightforward linear model, but now it allows you to apply different sets of weights to different features. So maybe it's not just the neighborhood, and maybe it's not just the bedrooms or the size of the house, but maybe you now want to add in other things like the school district, or you want to add in other features such as how many stories it has. Whatever it might be, there are a number of different what we call multivariate combinations that might be important to you, and now you need to be able to apply different weights to each one of those, because you may feel differently as you pair it up. If a house has a pool and 3 stories, then I give it a higher weight. If it only has 3 stories and a basement, I get, whatever it might be. This gives you the ability to start to create a much more realistic model. And that's really the power of where a neural network comes in. Except, of course there's an except, you got to chain it all together. So it's not as straightforward as 4 little boxes and every little box is marching their little hat on, like boop, 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 coming up with a value. Instead, you now need to almost spaghetti chain it together, because each one of these things, if you think about it, have an effect on the other, or potentially could, right? Yep. So you have to have that relationship in there, and then those weights need to carry through so that you can have what's more of this aggregate approach to weighting out your end price result. And that's how you get a much more accurate model. And this is what a neural network is in its most sort of simplistic definition. Starting with a very simple linear example of the home price, then taking it and saying, well, what are the other things that I care about? And now saying, well, how do they all relate together if I was to munch this all up and toss it in a salad bowl? That's what we have here, and that's really the neural network at its core. And so with that, I think I only have one more. And so, it's a really good example that I like to show people is that, you can't build much with a single Lego block. And you're certainly not going to become a master builder, that's for sure. But if you think about, building this zebra out of Legos, each block, once chained together, becomes something really magical. It starts as one thing, and it becomes something entirely different. I'm a huge fan of Legos, by the way, so if you couldn't tell. And so I think it's just the perfect analogy for the same thing with the neural network. You can start with a few Legos, and maybe you could build, what I used to build, like a silly little car, or something that I called a car. And yet I would watch my partner build like these crazy cool things, and I'm like, well, why can't I do that? And it just over time, as I built more and more and more and chained it together, I realized that I could. It's all about creativity. And that's really where I think my fantasy football model differentiates itself from how others approach this kind of modeling. Something I'm very excited about. I know anybody who's watching this who knows me is like, not again. She's always talking about that model.
It's okay. It's good.
And so similarly, this is from, if you notice, there's a little Mario in there. Nintendo came out many years ago with this, you can build your own Mario world. But in reality, behind the scenes, all it was, if you look at the screen, is a set of grid objects, right? You've got little boxes, and they go, in columns and rows. And even when you see, what are the different aspects on the screen, like the bricks or like the stairs, all of those are still just, 3x3 little tiny cubes. And so each one of those cubes represents one of those circles you just saw in that neural network spaghetti mapping. And so when Nintendo came out with this this application for people to build their own Mario world, on the back end, it was really a neural net learning from two things: how they played, so all of their gameplay, and then second, what is the structure of the world and what are all of the aspects that it could be. And then over time, it would learn and create an entire end-to-end game for you with just you building this first little screen. It was quite cunning. Yeah, I mean, it was one of those really early use cases of neural networks back before, most people, it was a long time ago, we'll just say that. And so, yeah, it's awesome to see companies who really embraced this many years ago and now, can reap the benefits of having things like the cloud computing and the things that, we offer, through Azure that make it so much easier. Mm-hmm. So now I'm going to walk you through a demonstration of my fantasy football model. This is the first time ever I have publicly shown it to anybody other than the people who read my blog and or follow me and ask for it. So all right. Yes, you're getting like a total exclusive here.
Perfect. Hey, Ryan, it's our first exclusive. I love it.
Yes, nice.
And if anybody wants me to sign their copy of a printout version that they're going to make, I don't know, that didn't even work out in my head, but I will do it.
Perfect. She's going to do signed autographs. I love it.
So you can see here on the far left, I just want to show you from a structure perspective, this was written in R. This was written many years ago, and so I have since started to edit this in Python. I think there's a lot of benefits to using Python over R, but it's really a philosophical debate, which one you want to use. If you're more comfortable in R, continue to use R. The reason why I believe Python is better is it has a lot to do with how multiprocessing and threading Python is just organically. Whereas with R, you have to do some wrappers to make it behave the same way, but you can get there. So I don't want to downplay one over the other. But this one is in R, and this whole project started with my father-in-law saying to me, statistics will never win fantasy football. And I was like, what's fantasy football?
Challenge
and he was
accepted.
Like, oh yeah, the gauntlet was thrown. But it was thrown and I knew nothing. I was like, this much. So, I mean, it took me that first year to just ask a million questions of everybody I knew, like what's PPR, what's standard, what's this, what's bench, what's play. And then after that year, I started to build. And it was into that second year that I started to train for the first time based on these factors that I learned. And my end result was crap, and I lost that year. That was the first year I actually played. And so the second year I said, I'm going to take a slightly different approach. I'm going to go out and I'm going to pull in all sorts of stuff, everything from, all of their draft day to the combine, when they come out of college, to all the historical, of course, to then social. And I think social is one of those things that really differentiate this, because I go out and I scrape everything from their social sphere that they may touch, Instagram, Twitter, Facebook, anything that's publicly available, because I had a hypothesis at the time that players who have these crazy events going on in their life, like getting arrested and, things happening with their family,
probably would impact their play.
Yeah. Right?
Imagine that.
And conversely, those who maybe just had a baby, are maybe going to be a little bit more, or got married, because maybe a baby would make them tired, but, people who had positive things would probably feel like a little bit more energized. And it turned out to be totally true. And so that's what I started doing in that next year, which is pulling in a million other points of data that I could actually get in here.
So how do you score the sentiment in posts? Or maybe I'm stepping ahead, but I mean, was that a complicated process when you have something very abstract that could really be free flowing? You have different phrasing from one player to another. Like, how do you? Is that challenging to get a model to be able to score that?
Absolutely. A lot of people go down, an NLP, which is a neuro-linguistic program path. It's very common, but doing that, you have a lot of false positives. And if you remember my picture of the male who was pregnant and the female, who clearly had the belly, who wasn't pregnant, essentially it's saying, I think that this, piece of commentary is negative, and it may be positive. It may just be slang. And so what I also did to really enhance that part of it was I created a slang dictionary of all of, I would listen to interviews ad nauseum. I would record them doing their interviews on ESPN, on NFL.com, so I could learn the slang of the football player. And I actually think it really helped in training my model on what is good and what is bad in terms of that sentiment. So yes, it's a very challenging thing. It's one of those things that's still challenging today. I mean, there's a whole host of things you can do with creating stop word lists and M-grams, but that's going into way too much detail. But one of the great things I think Azure does is, the cognitive services offerings that we have simplify a lot of that. On the back end, they're very complex, oftentimes neural networks that are happening, but you don't see any of that. It's abstracted away, and it's made very simply for you, where you just plug in your text and you get your sentiment score, you can tweak it and get your new sentiment score. Very, very simple. But I didn't have that, unfortunately, when I started this.
Okay.
So just wanted to give you, a framework of the kind of stuff I pull in. Now, during football season, this is updated. I update this every day of the week because of injuries that occur during training, and any changes that may occur to, dropping a player, picking up another player. And so, one of the funny things is, I haven't updated it for this year. And so it's a huge update when it's that first time of year. And I think, it was still, 43%, and it's been running for 7-8 hours. This is one of those points of, where there's two things. R is, in my mind, my own personal humble opinion, it's just a little bit slow on stuff that really needs a bit beefier compute. I mean, I'm using a GPU-based VM right now. So, I mean, I'm backing it with some, but it's still, sort of slugging along. I mean, I think if I had tried to run this on any other type of VM, it would have failed. So at least we're cooking with gas. But the second thing is that when you start the football season out, you have a ton of new people, new data, all sorts of different points. People change teams, and that's where the model needs that time. I think I'm involved in 6 projects right now where we're building neural networks, or I'm building neural networks. These are not simple things. These are, while my picture of spaghetti made it look simple, if you saw, the number of lines of code to really to create a neural network, it's a lot. And so I have a notebook here just to walk you through some of the sort of end result visuals, because I thought that might be an easier way to portray it. But essentially, it's probably roughly around, I think I counted it once at 42,000 lines of code. I've written maybe 70 custom functions. I have a library that's actually published in PYPL, so you can install it. So it's an open source library that has all the football backend data. That's something new and exciting this year. It's one of those things that it's been a labor of love. But I just, to share some of the results set for you, and then I will move on. I thought, out of all these crazy data points I have, I was just like, let me pull some to just visualize this using these notebooks. I'm a huge fan of the IPython notebook because it gives you that ability to script out and visualize at runtime, so you're not having to compile and then wait and see. So for me, it's like I'm a very visual, tactical person, obviously, and so I love to be able to see, boop, I got an error. Well, I don't really love that part, but, who loves debugging? But, it's great that when it all works, it's always like, yes, I get such a satisfaction out of it, so it's beautiful. Okay, so this first view, and I was just talking about this to my partner, I said, this is the top 100 players at the end of the season based off of just points. So you imagine you rank, from the top to the bottom at the end of the season, so that way it normalizes out things like, injuries or people that got pulled out, because naturally they're not going to be in the top 100. They would have filtered out to the bottom. But what's interesting here is what you're looking at is all the variance in their play. These are standard deviations, and if you know anything about statistics or not, think of a mountain. In the middle of that mountain, if it was a perfectly curved mountain, is no standard deviation, meaning you are spot on, you are precise, you don't have a lot of variation in what you do. Yes, that's not me, but yes. Mm-hmm. But then, as you move farther away from the middle of that mountain, you then step 1 standard deviation, 2. And as Six Sigma says, it's that 3 standard deviation point when anything below that is just a defect. It's a mess. You need to fix it. So if you imagine looking at this here, this is my middle point of the road. And these are the players, over the season and how they played. Those players that you go out and draft at the beginning of the season have a ton of volatility positively, meaning if they go up, that means, from a projection perspective, they're going way above my projections. Great. But that's still very statistically hard to then bank on, over time. But look at, the players 9 through, roughly 15. Who were going down. These are the people that people drafted really early because they were supposed to be super awesome, and then they turned out to be big fat duds. And so I thought it was just very curious to then look at those guys who cost a ton of money to draft versus look at how nicely tight these guys are more towards the top 100. They have a lot less variation. While there is this pool here that's like a no-go, there's this nice little pool here of people that are cheap to draft if you're in more of a DFS or a draft type auction, but they're also very consistent around that mean, which means very easy to predict consistently week over week. So I thought that was a really interesting way to show the end results of the season, just taking a slice of that data.
I think somebody has a product that NFL drafters might want to buy.
I was thinking that also.
Oh, yeah, I know.
I just want to talk to people in the NFL. I think I've been sweating our internal sports people like, hey, can I tag along? Hey, can I shadow you? I just want to talk to them. But no one ever takes me up on my offer.
No, I think they will after seeing this.
And so, just some of the other things to just walk you through of how I can use the data that I'm collecting. By the way, this is all running, as I said, on Azure's, GPU, NC, awesome VMs that just really are built for deep learning. They give you the ability to put a lot in memory, so that means you're not having to reduce your training set. I mean, you can imagine the volume of data I have is massive.
Oh, yeah. That's a great point that you call out, just from where does someone run this stuff. So that's a really interesting, and I think a lot of people don't understand is the CUDA-based calculations, the interfaces there are extremely powerful rather than running this across lots of VMs from a CPU perspective, right?
Absolutely. Don't be afraid of the sticker price, because if you were to take multiple different VMs and have to chug them through and still hit those memory errors, you would spend way more.
Oh yeah.
So how are you off scheduling the execution of this? So are you just installing your packages on these machines and running it directly, or are you using any sort of engine to like Azure Batch or anything like that to be able to distribute that work?
That is a great question. So I've just finished beg, borrowing, and stealing from the Project Brainwave team, which is our new FPGAs. Woo! The new chipset we have. I don't know if you know a lot about them, but basically it's, now we had CPU, then we had GPU, but now we have FPGAs, and that's going to really enable some amazing type machine learning. So point being is that they're not available to anyone yet, but I think I just got access to one. So to answer your question, yes, this will be run through what's called the AML real-time AI to be able to batch up and do this on an automated basis. Right now, it's kicked off from a Python job that goes out, and it's really janky, I know, but I'm a Python gal. But it gets the job done. However, the batch will be so much better.
Okay.
So what this is telling you, and again, it's funny, I only started to look at this way for this particular session. Normally I just take the stats out of it. I've gotten so used to what I do. But what this is telling you here is, these are the points that I project for any given week. So I know it's embarrassing, but I won a lot of my games by getting under 100 points. It just happened to be the weeks my competitor had terrible luck or something would happen. Yeah. But you can see here from a consistency perspective, what you want to see around, your trend line here, or this line that is your prediction, is a very small, light gray area of variance, very similar to the graph I showed you above. That means you're very close. You don't have a lot of standard deviation in your predictions. Now, what you're looking at up here are the actual fantasy points. So my sweet spot, sadly, happens to be in this. I mean, it's crazy. I won on weeks with like 55 points. And you can see that represented from a statistical perspective right here, meaning that I came in very close to what I projected. But as we get bigger and bigger, so say there were weeks where, I had the number 1 and the number 5. I just had some great people before injuries, and I projected a lot of points, and then they just bombed. That's what a lot of these dots you see in this upper quadrant are. And in the lower quadrant is where you see me underbidding them and them coming in underbidded. So.
But I'm not a data person, so and trying to, for me personally, just trying to understand this graph. One of the things I think that stands out the most, though, is, and I think a lot of people are like, I'm not winning big all the time. That almost seems like a statistical impossibility. What if I'm doing a consistent, stable predictions, even at smaller intervals, you're killing it, And I think that's one of the things, just from me standing out from this, is like, I'd want that lower left quadrant, not trying to shoot up to the right, because it seems like winning the lottery every day. That's impossible.
Right.
Versus
it is.
Winning small lottery amounts over and over and over and over again. Die by 1,000 cuts. That makes sense to me.
That's an excellent point. And, that's something it's been very hard for me to rationalize because, ever since the gauntlet was thrown, I wanted to be bigger and better and to crush my father-in-law.
Right.
Yeah. But you feed them little bits.
Yes. Absolutely, that's a really good point, and I didn't actually even know that until I put this together. I thought, I had and that's one of the great things about machine learning is that you may go into something having this impression or having, a supposition that it's this way, as most of our customers do. Right. We believe these things are important, and we don't know why. We believe it. We know the business, and it turns out.
Yeah, go ahead.
No, I was just going to say, and it turns out oftentimes they're wrong. There's other things that they're not even looking at that are important.
Now, I'm going to make a substitution here where think of this as a cancer data model where people are looking for the absolute perfect cure up to the top right rather than small reductions, small improvements over combined periods of time lead to a better outcome from a cancer treatment perspective. It's like if you gave this to the data scientists in those clinical trials and they saw this model, they'd be like, well, there's not my miracle drug, but it's all these components that come together, which... quite frankly, that's how they're starting to figure out cancer is a waterfall of events. Then you can solve for that. And this is blowing my mind from like, oh, wow, this can apply through so many different fields.
Right, absolutely. Right. Absolutely. And, and to your point, in talking about these new chips that are coming out, now that we're going to have even greater ability to have things in memory, those cancer scenarios, will actually be possible. We won't have to sample data and try to, piece it together. We can actually run full model sets, which is, for me, so exciting to see.
Yeah, great.
Wow, okay.
All right, one last just little visual here that I thought was interesting. Okay, so on a PPR team, or at least my league, when you're drafting, there's a strategy where you should have, X number of, your first wide receivers, but then your benched wide receivers. Same thing with your running backs. So that way you can swap them in and out, and if they get injured, you have somebody on the bench. Well, I had 3 wide receivers because I had one in the top 10, one in the top 20, and then I don't even know where the last one was. So what this graph is showing you is, okay, so remember, keep in mind always the standard deviation. So you want the graph to be as narrow as possible. That my number one, which this was 2016, so it was Tyreek Hill, that's his nickname, and he crushed it that year. I mean, he was a consistent, like every week, and that's what you see here. This basically says with an 80% probability, he is going to achieve the projected points that you predicted. So he was always a player for me. But now, what about the bye week, the weeks where they're not playing, or if he had been injured? Well, okay, here's my other two. Now, if you notice anything interesting, first, I was like, well, my third one is super inconsistent because he's just got this flat blue, like, bleh, and it's spreading all across the graph, which means bad, good. It's just, and you can see with the probability of maybe, 16%, like, not a good one to bank my model on. And then, the secondary one, he at least had a tighter curve, but again, my probability went up to about 25%. So, what this told me is, my draft, I did really well in terms of when I picked these guys, because this guy here was my first pick, and he clearly, he equated to the value of being my first pick.
Right.
And realize this whole model has a whole drafting section in it. So when, auction time starts or when draft time starts, you know who to draft in what round and what value that'll bring to you, because I assess value points to everything so that it can be applied to PPR or DFS, more the auction style. And so, yeah, this was just another one of those validating points that even though my gut told me that he was a super, baller, he's the consistent guy I want to bank my money on.
I love it, super baller.
Pun intended. And so, this is just to give you an idea of some of the ways you can use the data that comes out of these neural networks. And while the code, as I showed you in R, or whether you're looking at it in Python, I'm sitting here on this VM in Azure, it can look very complex. You can piecemeal out components of it and visualize it. And one of the great ways to do that is once you find visuals like I have, go to Power BI and create a dashboard that has these particular metrics in it, because this gives you the sense of, oh yeah, this visual is talking to me and other people understand it without a lot of explanation. Let me now build my dashboard, almost using this notebook as a prototype tool to be able to then have a much better dashboard. At least in my experience. Otherwise, you get a machine learning dashboard that has a bunch of rigmarole, maybe some sign charts, like not everyone's looking at oscillations, people. So you want to be able to create something that's business friendly and valuable. And I think this tool, from a data scientist perspective, gives you the ability to take out just little pieces of information, almost KPIs, but to put them then maybe ML KPIs, and take those then and augment and or create your own dashboard.
So could you give some examples of how you've extended these sorts of concepts, or do you have like a simple customer example that maybe you could outline? You don't have to go into great detail, but just to extend this into not that this isn't real world, because it is, but just like a business scenario.
Yes. So this NSynth, so let me back up. So we have a customer who is an HVAC and parts giant company, and they wanted to do basically starting with object detection from images. So their technicians wear body cams. They go into a house or a business. There's an HVAC system, and they oftentimes have no idea what part is, to order the parts, where to even go to look for it. And then if there's a sound and the customer's like, it's going clank, 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 the guy's like, okay. They have no idea what this is happening. So they tasked me with two things. First, off these body cams, can we automatically detect what the part is? And zoom in and understand that this is that part, and then have it tied back through Azure Search or other things to things like documentation, maintenance guides, and the order replenishment system. So that's very sort of common use case where you could take object detection or image recognition and not just apply it to faces or snow leopards, but apply it to things that are in real world business. And in this use case, there's no manufacturing training set out there like there is for people's faces or for animals. This is something we had to create from scratch. And I'm very proud of it because I think it's a whole new business model for them where they can be the manufacturer that you go to now because they have that training set of information. So what I was saying is, okay, so we started with this image recognition piece, and we had tremendous success in terms of accuracy, how often the model was correct in picking out the right part. And then we also had a tremendous precision score. And precision, if you think about a dartboard, there's two metrics you would look at. Your accuracy is, can you hit the bullseye? Your precision is, how many times can you repeat and hit the bullseye? So can you be consistent and repeat it over and over again? You'd have a high precision. If you can only hit the bullseye once, your accuracy is going to be super high, but your precision would be super low. And so we had a very good baseline for them in terms of both of those metrics. So, accuracy was in the 90s, which is tremendous. Precision was a little bit lower. It was around in the 80s. So they wanted to improve that. And that's where sound came in, and that's, what brings me to InSynth here. So they wanted that clank, 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 clank customer to, to take that sound, and if you could hear it in the HVAC from the body cam or the HoloLens is where they're going now, they wanted to automatically have that brought in and stored, and then have the model then trained on, can it disambiguate that sound and correctly associate it to what's wrong?
Wow.
Isn't that awesome?
That's insane.
Yeah. That is
so to prove it out, because this is just something they announced at Build. I mean, it's been around for a little bit, but at Build they announced that we had, this whole new SDK that was really going deep in this area of audio and noise machine learning. So I went to what the equivalent, I guess, Dave & Buster's. I don't know if you have those, but I assume you know what they are. It's like an adult, fun place, Chuck E. Cheese. And I recorded everything from skee ball noises to the foosball table noises to, all video game noises, every noise I could possibly record. And I said, I want to see if I can train a model to successfully determine what the game is that was being played. And if I can do that, then I'm going to go back to this customer and say, hey, I think we are getting very successful at, what your big vision is. And so I went ahead and did that. But when I did this, I hate to admit it, but I used a competitor product because it's just my background and coming from TensorFlow. And so, TensorFlow we use on Azure all the time. A lot of our models on the back end are back-ended by TensorFlow, which not a lot of customers realize. They think it's either they use us and our libraries or they use this competitor and TensorFlow. That's not the case. We almost every one of our cognitive services or our models are actually back-ended by TensorFlow. So, I'm really not saying anything bad here. I'm just doing what everyone else does because it's very successful. So in using in building out these sounds, I was able to upload each of the different files that I recorded, and so you can see here, this had the ability to play sound earlier. So I apologize. I was really excited where I could show you the sounds, but it got stripped out for some reason. So I'll make them for you. Okay? It was like ding, 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 ding. That's what you see here.
Okay.
And then this one that you see here, each of these different colors represents a line of sound that was happening. So if you imagine the ambient noise factor of when you have overlapping sounds, well, that's clearly what happens a lot at Dave & Buster's. So you can see here how this middle section is just this spaghetti nightmare of overlapping sounds, but there were some very distinct trails of, skee ball, video games, and so forth. And so that's really what you're seeing here is the ability to take an audio sound, a sign, and translate it into text or numbers that can then be analyzed. And I love that. I mean, to me, that is super exciting to take, both pictures and translate them into pixels and take sound and translate it into number. I mean, it's just so mathematically binary. It's like, oh, yeah, I'm a happy woman.
Take something very, you think about the brain power involved in processing, a sound and how you can take something that we take for granted and distill that down into, essentially mathematics and be able to analyze it here. That is pretty cool.
And imagine, you might be thinking, well, how is this ever going to apply to me? But they're now using similar machine learning models now to create all new music scores, all new, write books without anybody ever touching it, by training it on maybe the authors that you love most. I mean, there are so many cunning use cases. I mean, this manufacturer that we're working with, there was no, let me go to Google and find, a publicly available machine learning model to start with. There was none of that for this sphere. Predictive maintenance is one thing that everyone's talking about, but they don't realize until they get into it just how much data you need and how precise it needs to be. And so image recognition and sound recognition are two things that I can think of a million different scenarios that they apply to, say in a hospital, when you buzz the nurse, that sound can be picked up and cued as being how many times did a patient have to buzz the nurses to come treat them, you know, in terms of a better customer service program. Or, you know, as you're running around the floor, the code blues or the code whatever that you hear overhead, all those could be trapped and recorded so that then we can, you know, store and analyze them later. Or the McDonald's example that we talk about all the time.
Yeah, I mean, I can tell you from a healthcare background, this could be used in NICU or ICU. The changes in a patient's breathing are indications of respiratory stress or failures. You know, you could detect things before even a lot of the monitoring on the patient can actually take effect. That is crazy.
It's crazy, right? And
yeah.
When you overlay the emotion APIs, which is, you know, the ability to add context and really internal sentiment to what somebody's feeling, then you think about things like, I'm calling my insurance agent and telling them that, oh, this happened, when in fact my voice is saying, you know, that I'm lying. Or maybe, you know, as a lie detector test to the police.
Look out, Ryan.
Yeah.
They're on to you now, buddy.
I mean, there's just such a vast use case that this could be applied to.
The patient one is really interesting because I taught, you know, some friends of ours, he's a trauma surgeon, and he was talking about like in ICU that he went there recently, and, you know, they have these nursing stations where they're observing a bunch of different patients. And, you know, long story short, that there was some, you know, patient that wasn't breathing the way you and I, you know, all of us would breathe. They were breathing, and, you know, for their vitals were okay. But, you know, he said he asked the nurse, and she said, well, he's been like that since since I've gotten here for my shift. The thing is, it was not normal. So
no.
You know, so having something like this to be able to say, yeah, I might have been doing that, you know, consistently, but it's something you should maybe pay a little bit more attention to.
Oh,
yeah, we have a very young workforce, you know, coming out of college and entering the work field today, and they don't have all those experiences like this nurse probably didn't have to know that that sound was bad. Just like the technician in my example doesn't know that that part or that sound means this. So if you can tie that together and make it simpler for them, just think about how that flows down to the customer. I mean, the work order is faster, or the treatment is faster and better, and they're less frustrated because they don't know what's happening.
Well, now you think of the upflow of the business model now, you have more effective patient care, which should reduce the cost of patient care, which then also means better outcomes and better health systems. I mean, you can turn from, you know, from pay for service to pay for outcome. You know, these are the big models in the healthcare industry that are trying to change, you know, America's big bloat in the healthcare industry. But this is incredible. My mind's blown at this point.
Yeah, no, and I mean, that's what's so exciting to me about, you know, so for example, Satya talked, I think it was 2 years ago at MGX, Satya being our CEO, about the McDonald's use case where, and nowadays, if you drive through McDonald's drive-through, that's not a person actually recording down your order. That is audio that has been trained and learned to pick up everything that you're saying that you want to order. So I want a Big Mac, a Happy Meal, some fries, and you imagine all the noise that happens in a drive-through, and yet the accuracy is amazing. And when you see it on the back end, when you actually see what's happening, you know, you see this big blob of text accurately getting, you know, placed into a JSON format, so now it can be, you know, stored and searched and queryable and powerful. That's how you take the sort of nebulous idea we're talking about and translate it into, well, how would I actually implement it? And that's the question, you know, that everybody goes down. But you can't ask that question yet until you actually start to collect the data. Because McDonald's, well, they had tons of voice recordings of all the years of people going through drive-thrus because they wanted to improve the drive-thru experience before, you know, the machine learning part. So they just happened to have them. But in our case, you know, we have to do tests with some of the technicians to start to record, you know, their day in the life of, you know, when they're with a customer. In the healthcare industry, it would be the same way, where you would need maybe doctors wearing body cams, or even, you know, the HoloLens examples, something that could record a lot more of the sound that they experience on a day-to-day basis, and that we could then start to train and learn. That is the first step to making this happen.
Very cool.
Yeah, that is very cool.
So do you have any questions? I mean, I know that was a lot of information today in terms of the demonstration. I wish I could play these for you because it was so cool. Like, these were the original sounds. The reconstructed sound, this first one, which was Skee-Ball, was not very accurate. But this one, which was, I don't remember which video game it was so precisely accurate. It was crazy good. But, oh well.
Yeah. And that was extracted out of the file that you had to have them all combined, right?
Right.
Okay.
So all of this. So what happens is up here where you see them, taking the wave files and understanding the shape of them. I went through and then it started to sample pieces of it and created, an upwards of 2,000 by 32. So 64 or 640,000 training sets, so that we could then teach it what each of those different sounds may be, and then when they're strung together, what that looks like, and that's what's the interpolation. And so what you see down here is its ability to say, well, this is what you gave me, these two. Now I'm going to reconstruct it, almost like you think of a forecast. It would be like the nursing example with that cough. You don't want to incorrectly assess that cough is pneumonia, so you want to make it as accurate as possible, and that's what it's happening here. It's taking those sounds and reconstructing them, and then lastly mixing them together if that's what you want to do, because I went wild. But it's quite amazing to see where we are today and the ability to do this. And so if you do have those healthcare examples, I would, and they are visionary, I would love to have that conversation with them. I mean, I just think it would be very valuable.
Well, I think that's something for our viewers, don't you think, Ryan? Is like if you've got some guys out there that have seen our shows, and especially, Laura's episodes, and you have these types of ideas, reach out to Ryan and I, and we'll definitely connect you with Laura.
Yep. Or if you're
thank you for not giving out my email address.
Yeah.
Oh no.
Yeah.
You don't, I won't, right?
Well, very cool. This is I like how you take these very complex topics and distill them down into something that Matthew and I can understand.
Yeah, especially Matthew. Yeah, that's the bar. Matthew gets it real good.
That's right. Yeah.
Yeah, I used to take that as an insult when people would tell me when I was younger, like they were like, "Oh, I'm so dumb, I'm dumbing it down." And as I've gotten older, I've realized it's quite a challenge to take complex things and explain them just in general. And so, thank you, I appreciate that compliment. And the offer stands not just complex. If you have a model or you're stuck on something, because I'm always in the algorithm level of scripting. Anytime you get stuck, I'm definitely willing to help. I help multiple different customers. They're not mine, just because I enjoy doing this. So please reach out to me anytime, and I'm more than willing to help.
That's awesome.
Oh, now you've asked. Here it comes.
Oh boy!
Just tweet Laura. I need help.
Yeah.
Oh my gosh, my DMs are gonna blow up. Like you said.
All right. Well, thank you very much, Laura. This is cool stuff. And like I said, I really appreciate it. Definitely looking forward to kind of hearing how you apply some of this with some of your other customers, maybe having you on in the future.
Yeah, I would love to come back once we get some of this stuff fully baked. I know we're presenting it at Ready, which is coming up in a few months, but I'd love to come back and show you some real-world examples that we're implementing.
Cool.
Excellent.
Okay. Well, thank you very much.
You're welcome. Bye, guys.